So let's look at the first sample problem. And all really we're going to be looking at is, well, stoichiometry continues, right? Stoichiometry continues with concentrations. We've seen in terms of mass. Now we're looking at it in terms of volume and concentration, right? So key equation to remember, right, when dealing with concentrations and when dealing with volumes is the pyramid of concentration is equal to the number of moles over volume, right? And remember going back to several chapters back on how to use that pyramid. So let's look at the first problem. 13.84 milliliters of hydrochloric acid, HCl, aqueous, just neutralizes 25.00 milliliters of a 0.1000 moles per liter solution of sodium hydroxide. What is the concentration of the hydrochloric acid? First step is what? Whenever we deal with these type of equations or these type of sample problems. Write the equation. Okay? Take a moment, put together your equation, and devise a plan to try to calculate the concentration of the hydrochloric acid. So we've got the acid, HCl, the base, NaOH, the ionic salt, the ionic compound of sodium chloride, and water. So, from the information that we have the following. We have 13.84 milliliters of the hydrochloric acid. Remember, anytime we have milliliters, we want to change it to liters. So 0.01384 liters. When converting it, try to keep it to the same number of significant digits as you start off with. Right, you see 4 significant digits, keep it to 4 significant digits. We've got 25.00 milliliters of 0.100 moles per liter solution of sodium hydroxide. That's what we're actually going to use. Because from the information we've got here, and we're going to convert this to 0.025, I'm going to put in the 00, but we're going to just put it off to the side for when we're solving it, liters, right? Just to kind of make things a little bit cleaner. But using this information, what can I find using this and this of sodium hydroxide? What will that help me find? Remember, think of stoichiometry. What are we usually trying to find? Moles, right? We're trying to find the number of moles that were actually used in this reaction. All right? So we can do that because look at the units here. Moles per liter, liter. So what will cancel out? Liters, which will give us the answer in moles. Right? So using this triangle, right? We've got concentration, we've got volume, right? So we're going to cover up the number of moles. So the number of moles of sodium hydroxide, NaOH, is equal to C times V. So we're going to multiply our concentration by our volume, so 0.1000 moles per liter times 0.025 liters. And now notice here, I decided to drop the 2 zeros just to kind of keep things a little bit clean. But remember, what are the least number of significant digits in my question? 4. So make sure, right, that you don't round off anything less than 4 significant digits while you're working on it. Okay, try to add an extra 1, extra 2. Right? Remember, we don't want to round off till the very, very end. So when we multiply the 2 together, my answer, I wrote it down in scientific notation, times 10 to the power of -3 moles. So these are the number of moles of my sodium hydroxide that I'm using in this reaction. Right? But what is the ratio between these two? It's a 1-to-1 ratio. So because it's a 1-to-1 ratio, the number of moles of HCl that I'm using is the same thing, right? Because it's a 1-to-1 ratio. It's the same thing. So we don't have to make any additional calculations. So I know I've got the number of moles of sodium hydroxide is 2.500 times 10 to the negative 3, and the number of moles of hydrochloric acid is the same, 2.500 times 10 to the power of negative 3 moles. Now, because I have the number of moles of hydrochloric acid, right, what other information do I have of hydrochloric acid in this question? The volume, right? So now, using that pyramid, I have C, I have N, I have V. I have the number of moles, right? I have the volume, right? I need to find the concentration. So C is equal to N over V. So the number of moles is what I just found. 2.500 times 10, negative 3 moles. I'm dividing it by the volume that I've been given here. 0.01384 liters. When I divide the two, I get 0.1806 moles per liter. So, the concentration of the hydrochloric acid in this reaction is 0.1806 moles per liter. Right? As we said, 4 significant digits is the least number of significant digits in my question, so I want to make sure that to include 4 significant digits.